Hello, we are back, continuing with the revision for Maths Paper 1 June exam. So question 2 now, arithmetic and quadratic sequences. Let's do these questions and see. The first term of an arithmetic sequence is -1 and the seventh term is 35. Question 2.1.1, determine the common difference of the sequence. So they're looking for D. And from here, we can see that we're given that T1 equals to -1, and we also know that T1 is negative, it's A, so A is equals to -1, and we're also told that T7 equals to 35. So we're going to use the general formula to solve down below here. So Tn equals to A plus n minus 1 times D. So all we just have to do is substitute. So we know the value of A, we have a term number 7 with its value there, so we can substitute here and there and then calculate the value of D, which is the common difference. So let's do that. T7 is 35, the value of A is -1, which is the first term, plus 35 is the seventh term, 7 minus 1 times D. So all you just have to do here is simplify. So if I bring this -1 to the left hand side, is 35 plus 1, giving us 36. On the right hand side, we remain with 6D, dividing both sides by 6. So the answer of the it's 6. 36 divided by 6 is D, is 6, which is 2.1.1. So this answer here is 6. Question 2 says, then determine the number of terms in the sequence if the last term of the sequence is 473. So we are looking for n, the number of terms. If we can know the n of the last term, therefore we know the number of terms in this sequence. So again, we're going to use this general formula. Now we know the value of A and D. So Tn equals to -1 plus the value of n. Okay, n is the general, is the number pattern, times 6. So we have to simplify this. So the next step now, we can substitute the term number 473, the value of the term number 473, because we're looking for its term number. That is -1 plus 6 times n, 6n, -1 times 6 minus 6. So all we just have to do is simplify. So -1 minus 6, that gives us -7. When we bring it to the left hand side, that is a positive. We add, is equals to 6n. When we add this two, what do we get? 473 plus 7, that's 480, equals to 6n. Divide both sides by 6 again. Then we get that n equals to 80. So we have 80 terms in this sequence. That's the number of terms. Next question, question 2.1.3, this one. Determine the sum of the first 40 terms in this sequence. Okay, so we are looking for Sn, where n is 40. So we're looking for S40. What is the value of S40? So we know that the general formula for determining Sn is given by n divided by 2, open bracket, 2a plus, open bracket again, n minus 1 times d. My apologies with that, times d. So what we're looking for is S40, the sum of the first 40 terms. So n is 40. Doing the substitution, we know the value of a, that's -1, plus n is 40 again, minus 1 times 6. So when we simplify this one using a calculator, what do we get? Let's quickly check that. So that is 40. That is 40 divided by 2 multiply by 2 times negative 1 plus 40 minus 1 times 6 close bracket, we get 460. No, my apologies, it's 4640. That is the sum of the first 40 terms. Question 2.2, this one, it says, okay, we're given this sequence here, 75, 53, 35, and 21. It is a quadratic number pattern. Okay, good. The first question, write down the fifth term of the number pattern. Okay, so the first question there, let me write down the sequence, 75, 53, 75, 53. What else do we have? 35, 21, 35, 21. So the first question, we're looking for the fifth term. So we're looking for the value of T5 here that we're going to find here. Okay, so let's do this. Let's do the differences there. So 53 minus 75, it gives us negative 22. 35 minus 53 gives us negative 18. 21 minus 35 gives us negative 14. And now we're going to look for the second difference, negative 18 minus negative 22. So that is negative 18 plus 22, or we can say 22 minus 18. It gives us a 4. This one as well, negative 14 minus negative 18 gives us a 4. And then after that, now we know that the second difference for a quadratic term is constant, so this difference here also has to be 4. And now negative 14 plus 4, what does it give us here? It gives us negative 10. And 21 plus negative 10, what does it give us? It gives us 11. So this is the fifth term. So 2.2.1, 2.2.1, yes. The fifth term, T5, is equal to 11. 2.2.2, determine the nth term of the number pattern. So we need to determine the nth term of the number pattern here. So give me a moment. Okay, so we're looking for T n a n squared plus b n plus c. We're looking for this general pattern here. So about quadratic sequences, we know that the second difference, that is equal to 2a, and this first difference here, it's 3a plus b, and the first terms here, it's a plus b plus c. Right, so this a plus b plus c, 3a plus b, and 2a, they are determined from forming a number pattern using this general formula here. For n equals to 1, you get a plus b plus c. If you substitute 1 on n here, 1 squared is 1, b times 1 is 1, so that's the first term. The second term is 2 squared, which is 4a, plus 2 times b, 2b, plus c, go up to n, 3, and 4. And then from there, we do the differences. Here, you would find 3a plus 2b minus b, that's b, c minus c, that's 0. So that's where the 3a plus b comes from. The 2a, when you do the difference again, if you do another difference here, and you'll find that here it's 2a. So the first part here, a plus b, is for the first term. So just wanted to quickly explain that if some of you didn't know. It's okay. I'm here to help you, and we're here to help each other. If I make any mistakes in the calculations, please do correct me in the comment section. I'll be happy to make adjustments. But So let's see now. Let's look for the unknown values a, b, and c. So 2a equals to 4. Therefore, the value of a here is 2, and 3a plus b equals to negative 22. Substituting the value of a, which is 2, we just found here, plus b equals to negative 22. So now here we just have to solve for the value of b. The value of b is negative 22. 3 times 2 is 6. Bringing it to the right hand side, it becomes negative 6. That gives us negative 28. That's the value of b. And as for the value of c, we're going to say a plus b plus c equals to the first term there, 75. The value of a, we know it is 2. From here, the value of b, we know it is negative 28 plus negative 28 plus c gives us 75. So if we simplify this part here, we simply get 2 minus 28, that's negative 26, plus c is equals to 75. Bringing the negative 26 to the right hand side, it's 75 plus 26. The value of c, therefore, it's 101. Therefore, our general term now is the value of a is 2n squared, the value of b is minus 28, and the value of c finally, it's 101. That's the answer there. So let us check. We've determined the nth term of the number pattern. The last question here says that determine the maximum value of the following number pattern. So I want you to think about this one, how you would solve it. How does this number pattern here looks similar to this one? How does it relate to the one that we were given in question 2.2 at the beginning? So we have a negative 15 as the first term here. Alright, while here we have positive 75. The second term is negative 53 divided by 5, while here we have a what? A 53. The next term is negative 7, while here on question 2.2 we have a 35. And lastly we have negative 21 divided by 5, while here we have a 21. So you can see that this term here was divided by negative 5 to produce this general sequence. So each term in this general sequence above here was divided by negative 5. So let's verify that quickly. So 75 dividing by negative 5, it gives us what? Negative 15. And as well as 35 divided by negative 5, it gives us negative 7. So we can use this general term that we determined in the previous question to make calculations for this term, because we know that we'll just have to take the general sequence from here divided by negative 5. Why? Because each term of this previous sequence here is divided by negative 5 to get the new sequence here. Okay, so let us do that. That's question 2.2.3. So the new term of this general sequence that we're given there, they take this sequence from the previous question divided by negative 5. So we have 2n squared minus 28n plus 101 divided by negative 5. Right? So I was just going to leave it like this, but let me just quickly simplify that. Minus 28 divided by 5. 5 doesn't go into 28 divided by 5. Yes, it gives us a fraction. Minus 101 that's a positive, my apologies, divided by 5. So we are looking for the maximum value of this sequence here. So basically we are looking for the turning point of this graph, because if we were to draw this it will be like that, because the value of a is -2/5. So this would be a set quadratic graph. It will have a set face, sorry, a set face. So this is definitely the maximum here. This is the maximum, the turning point, the y value of the y value here, which is the turning point. The y value is the same as the value of the term number. So that's what we're looking for at this maximum. So it's the y turning point, right? So remember, in other quadratic graphs, we've got a formula for calculating the coordinate of the x turning point. In this case, the x relates to what? The n, the term number, the n value. So we're going to look for the coordinate of the x turning point, which is the value of the term number, where there's the maximum term number, the maximum the maximum, determine the maximum value of the following number pattern. So that will be at the x turning point. So let us use the formula. That formula for determining the x coordinate of the turning point is -b divided by 2a, right? This is not the only way to look for the maximum value. You can also use the method of completing the square, which will take longer, but you'll still arrive at the answer, not too long. So that will be negative. The value of b there is my mistake. I've made a mistake here, my apologies. So that's positive 28 and divided by 5. So the value of b is 28 divided by 5, and the value of a is -2 divided by 5. So that is 28 divided by 5, all divided by -2 divided by 5. Now let's check what answer we get when we use the calculator. So that is negative, that 28 divided by 5 divided by -2 divided by 5, we get a value of 14. Okay, that's negative that. Oh, my apologies, I forgot to multiply by 2. There's 2 outside here. Multiply by 2, so we get a value of 7. So that's 7. This is the term number. So we find the maximum term value at the 7th term. So where is the value of that maximum term number? So now we're going to use this formula here to substitute 7 into that. So that's -2 divided by 5. Substitute 7 squared plus 28 divided by 5. Substitute 7, and the last term is -101 divided by 5. Minus 101 divided by 5. That will give us, let's see, let us check what we get when we do that. Okay, so that's -2 divided by 5 times 7 all squared plus 28 divided by 5 times 7 minus 101 divided by 5. We get -0.6. Let's see in fraction form. What is it? In fraction form. Okay, I don't have it in fraction form. So that is -0.6. -0.6 in fraction form. Let me 0.6. So that is -3 over 5. So that is the answer to this question. So we are done. That was the last question here. So we are done with the with this question. Question 2, arithmetic and quadratic sequences. Where is that answer? there is the answer. Negative 3 over 5 is the maximum term value of the sequence. So this is where we find, so this coordinate, it's 7 and negative 3 over 5. So yes, there it is. Thank you so much for joining me. If you have any questions, please don't hesitate to ask me. If you want to see the method of finding the maximum value by completing the square on this question, please do let me know. Otherwise, I suggest you go and try it on your own, and let me know if you get the same answer as me here or not. If you don't, I can later upload a video by showing you how to do this one, because it's an interesting question. I hope you found this lesson very useful and helpful in terms of your studies and doing revision. Please make sure you subscribe to this channel, MS Tutorial, Maths and Science Tutorials, where you will be helped with your studies for grade 11 and grade 12. Thank you so much for joining me. Don't forget to like this video if you found it useful. Make sure you like, so that YouTube can suggest this video to other people that might find it useful as you would have found it, and more people can be helped and all of you can pass.